Howdy folks. So I have a somewhat unique opportunity today where this morning I wrote a CAT file and then this afternoon I'm working on calibrating a Bosch P-pump for a Mack, and it struck me the odd similarities between the two. Those of you that play around with CAT ET, you know that CAT expresses fuel position in millimeters of rack travel, which is an archaic way of expressing fuel quantity. A lot of the new stuff is milliliters per stroke, or cc's per stroke, or cc's per thousand, or liters per minute, blah blah blah, goes on and on. But CAT chose to use the old-timey way, and it's very interesting that the maximum rack travel on a Bosch pump is 21 millimeter. The maximum rack travel in a CAT file is 21, actually I think it's 21.5 millimeter. But isn't that interesting that it is similar? So I want to show you just a little quick visual representation of how rack travel and plunger stroke are related. So here's an old Bosch barrel and plunger assembly. The helix, which is what controls basically the effective stroke of the plunger, is set on about a 45-degree angle. This is up in here. This is your spill port right here. So as this goes up and covers the spill port, fuel delivery starts, and then once the helix goes beyond the spill port, fuel delivery ceases. And then the further you rotate that, the taller the effective stroke becomes prior to the spill port being uncovered again. So the spill port is uncovered, it's covered. Once it's covered, delivery begins, and then as the plunger strokes up to the bottom of the helix, it's uncovered, delivery stops. So the interesting thing is we measure these Bosch pumps in millimeters per of rack travel. And Caterpillar also, even in the electronic engine, does millimeters of rack travel. So let me show you a little interesting thing here with a framing square and a level and a tape measure. So obviously the framing square is laid out in inches, but we're going to pretend for this demonstration that it's laid out, that these are millimeters. So if you put your level here at, let's just say 1.5 inches, and we're going to pretend that's 1.5 millimeters. You go 45 degrees off of that, because the helix is 45 degrees, you're getting roughly 1 millimeter of effective stroke. And that's roughly where a Mack or a CAT, they all idle within that rough range of about 1.5, 1.3 millimeters of rack travel. So you're looking at an effective stroke of about 1 millimeter. The example I'm going to use today is the file I wrote today. I wrote at 9.4 millimeters of rack travel. So 9.4 millimeters of travel gives an effective stroke of, I'm going to round up just for the ease of this video, 6.5 millimeters. So 6.5 millimeters of stroke based on 9.4 millimeters of rack travel. If you times that times the diameter of the plunger, which on the CAT, I think it's 10.9 roughly. I don't know, somewhere around there. That gives you, you can figure out your volume of fuel delivery at 9.3 millimeters of rack. Now on a Bosch, like I'm working on a 14 millimeter Bosch pump, so 9.4 millimeters of rack travel on a 14 millimeter plunger is a significantly higher volume of fuel than what 9.4 millimeters of rack on a CAT would be. So I'm going to grab the phone here off the stand. I was just going to do a bunch of videos and then link them together, but I think I can go ahead and do most of this in one take. At least all the quiet stuff I can do in one take. Say hi to Tiny and Yoda as we go by. Hi, Tiny. Hi, Yoda. Okay, so over here on the computer. Oh, come on. Okay, so this is I took a piece out of a torque regulating chart out of a CAT file that I wrote this morning. You can see, as your RPM goes up, your rack travel goes up. We maxed this one out at 9.4. You can see there's RPM down the left side, and then these numbers are all millimeters of rack, which is actually a fictitious number, like I just told you. But now, here's an interesting thing. Over here on the pump stand, we got our Bosch pump, and we have a dial indicator hooked up for rack travel. Now, I got this one set at 9.4 millimeters, so that's actually 9.4 millimeters of rack travel. That's a physical dimension of the rack, which is inside of the body. And what I'm going to do is I'm going to, just for the heck of it, we're going to run this thing at 9.4, and we're going to see how much fuel this Bosch pump puts out at the same 9.4 that I wrote into this Caterpillar electronic file. So I'm going to go ahead and fire everything up, and I'll be right back. And Boo Boo's going to cry and do what Boo Boo does. Right, Boo Boo? What are you crying for? All right, so this is a little loud. I got the throttle set at what's going to equate to 9.4 millimeters. I've got the fuel shut off, pulled completely off. Just kind of a random RPM here. And as you see, as I let the fuel stop off, this should come up to about 9.4 millimeters. And then I'm going to reach over and start the test. So that's all going to happen with a lot of noise. So I'm going to get my talking over with now. So here we go. All right, so there's some of the noise cut off. Okay, so I didn't look at this ahead of time, so this is kind of cool. We'll get to kind of see together. All right, so 9.4 millimeters of rack. That's 600 cc's per 1,000 strokes. So that would be enough fuel for a easy 1,000 horsepower in a 6-cylinder engine. So that's kind of cool. So 9.4 millimeters of rack on the CAT engine with 55s is somewhere around probably 750, 775. Whereas if you had that same amount of rack on this P pump, being 14 millimeters, you'd have enough for over 1,000 horse, and you'd be pretty close to 1,200 horsepower. We kind of double the cc's per 1,000 strokes on a 6-cylinder. But anyway, that was kind of cool. Relationship between rack travel, which was probably established in the 1950s, with electronic rack travel established probably in the late 1980s. So yeah, I guess that's about it. I better get on with calibrating this pump, but I thought I'd just put a little video showing the correlation between Caterpillar electronic rack control and Bosch mechanical rack control. Hope you found it interesting.